All right, happy Tuesday, week 3. Y'all made it this far. I'm really proud of y'all. It's so hard. New classes are so hard to kind of figure out the routine and how the teacher's teaching style and all that. It's always really hard. And first tests in a new class are pretty stressful as well. So we'll get that out of the way next week. So today is super important topics that I mean, don't I say that every week? So I feel like the Z scores are the most important thing we're going to learn today, and the lab. I I don't use a lot of box plots, but you will need to draw one on your test. So take good notes on that. I don't use median a whole lot in my real life anyway. I mean, I talk about median, but I don't do use the quartiles and all of that stuff a whole lot. But it's super interesting. You'll have some homework assignments or questions on it. Plus, there will be a test question about it, and I'll give you more detail about that once we get there. So, Z scores are a big part of the day. After we do the new material, we will go over lab two. Lab two is pretty fast. It does not take a super long amount of time. Um, to do because you already have your continuous data. You're going to use the continuous data from lab one unless you really want to collect more. That's totally on you. But you'll just use your continuous data from lab one so you don't have to collect more data for that. And there'll be some fun Excel tools that you will be using. So that's this week, or that's today, and we will get going. Okay. So I have an error here real quick. I'm going to fix it. So this right here should be sigma instead of, that's an ugly sigma. I'm going to redraw it. It's still going to be ugly. Okay, that's even uglier. So what a z-score is, a z-score is a distance the value is from the mean in terms of standard deviations. So you know that our outliers are any value that is more than 2 standard deviations from the mean. So since the edge of that interval is 2 standard deviations above the mean and 2 standard deviations below the mean, any value that has a z-score of greater than 2 or less than -2 is an outlier. So a z-score of 2 means that something is 2 standard deviations away from the mean. That's what that means. So our population z-score, it's really all about just notation. So it's, remember, the population gets the fancy symbols, the sample gets the boring symbols. So here, population, you take to calculate a z-score, you take the data value. I'm going to actually write it out in words. Take the data value minus the mean, and then you divide it by standard deviation. So this just tells you how many standard deviations something is from the mean. My Apple Pencil just jumped, tried to make a run for it. So a z-score is just how many standard deviations something is from the mean. It's unitless, so it's not like feet per second or anything like that. It is a unitless thing. It is just a score. So sample and population are calculated exactly the same way. They just have different symbols. We're going to do a few of them. One of the things I love that I do, so at the end of the test, I will give you at the end of the test, I give you all of the breakdown. So I will tell you the mean, I will tell you the median, and I'll tell you the standard deviation, and you can calculate your own z-score. So for example, if you took the test and you got a z-score of 1.8, you did really well on the test. So you are almost 2 standard deviations above the mean, 1.8 standard deviations above the average score that everybody else got on the test. So if you had a z-score of -2.3, you are an outlier on the lower end. You did not do very well on the test. Your test score is 2 standard deviations below the mean. So I'm going to post that in the discussion forums after I grade the test, and you'll be able to look and calculate your own z-score and see how's my score compared to the rest of the class? It's one thing that's great about z-scores. Right. So let's actually do some examples. One of the reasons we like z-scores is because it helps us to put everything in the same like units. It kind of standardizes it. So I can like look here. The average height of males 20 years or older is 69.1 inches tall. The standard deviation is 2.8. The mean height of females 20 years or older is 63.7 inches tall with a standard deviation of 2.7 inches. So we got this from the National Health and Examinations Survey. So obviously Kevin Garnett is taller. He's 83 inches tall. Candace Parker is 76 inches tall. But what we use the z-score for is to determine who's relatively taller. So compared to the average, which one of these is taller? Which one of these people's height is more standard deviations away from the mean? So I'm going to calculate the z-score for Kevin Garnett. So remember, it is the data value minus the mean divided by standard deviation. So my data value, he's 83 inches tall. The mean height of males is 69.1. And divide it by the standard deviation of 2.8. If you put this entire thing into your calculator, make sure you put parentheses around the numerator. Otherwise, your answer is going to be very, very wrong. So I'm going to put this in my calculator. 83 minus 69.1 divided by 2.8.
When we see the term relatively, does that always mean z-score?
Yeah, generally, yeah. If we're asking if somebody who's relatively taller or who did better relatively, so yes, because it's like relative to the mean, who's taller?
Okay.
Yeah, good question. So his z-score, Kevin's z-score is 4.96. That is a really high z-score. Considering outliers are anything with a z-score higher than 2, 4.96 is huge. All right, let's take a look at Candace Parker. So we take the data value minus the mean, which is 63.7, divided by the standard deviation. Once again, put your numerator in parentheses. So I'm going to do 76 minus 63.7 divided by 2.7. Her z-score is 4.56. While it is still an outlier, she's still way above 2. She is relatively shorter than Kevin Garnett because his z-score is further from the mean. His z-score is almost 5, whereas hers is about 4.5. So he is still relatively taller. So compared to the mean, he is still taller compared to the average. Questions? We're going to do another one of these. Don't worry. All right. Okay, here's another one. So we're trying to figure out who had a relatively better run producing season, the Los Angeles Angels or the Colorado Rockies. So the Angels scored 773 runs. They're in the American League. The mean number of scores run is 677.4. Their standard deviation is 51.7. So the Rockies, they scored 755 runs. They are in the National League. The mean number of runs scored was 640, and the standard deviation is 55.9. So I'm going to quietly, I'm going to write the formula first. Go ahead and calculate these z-scores. I'm going to do it quietly myself, but you go ahead and calculate them. If you get stuck, go ahead and look up. But I'm going to calculate the z-scores quietly, and I would like you to try them on your own. Give you a moment. All right, so the z-score for the Angels is 1.85. So their runs for the year, while pretty good, are not quite an outlier. They're still almost 2 standard deviations above the mean. So they did have a really good year. So they have a 1.85 z-score. The Rockies, on the other hand, their z-score is 2.06. So their runs, their z-score shows that their year was an outlier. They did a really great job. So even though the Rockies scored fewer runs than the Angels, their Z score is higher. So compared to the mean, and they did better. They did a better job relatively than the Angels did. So the Rockies Z score is 2.06, the Angels 1.85. So the Rockies they had a better season. Questions?
How would I know looking at that how many decimal points over? Because I did get one, I got 1.8. I thought that was it, but I didn't realize to add the 5.
Okay, so if you would have rounded that, make sure that you round it to 1.9 and not 1.8. Real important there.
Yeah.
But yeah, make sure pay attention to the number that's after it. Actually, I think, hold on.
Because it was
Nope, no,
1.849.
you're good. It would have been 1.8.
Okay, I was like,
Yeah,
okay.
I just lied to you. You're right. I just looked at my calculator again. It just do whatever my open math tells you. I usually round z-scores to 2 decimal places. Um, but just
Will the test always say how many to round?
no,
I
and
think that's what my fear is that
if it doesn't, if it doesn't say, then I won't mark you down for rounding to the wrong decimal place. If it doesn't tell you round to 2 decimal places or whatever, I just go with whatever you have. Just
okay,
almost never round to whole numbers. Always go at least one point after the decimal,
okay, thank you.
unless it says whole numbers. At least one. Z scores, I always go to 2. And that has to do with our Z table. So we're not going to use the Z table today, but when we use the Z table will have 2 decimal places always for Z scores. So rule of thumb, go to 2.
I
But
will do that. That makes me feel better for the test. I was like,
yeah, so yeah, just go to 2. But if I don't tell you where to round, then it's all bets are off, and I can't really dictate where you're rounding to. So
thank you.
you're welcome. Good question. All right. So now we're going to jump to median. So put z-scores in your pocket. We're done with z-scores for today. We're going to jump for median. So z-scores we only use with mean. Z-scores are only used with mean and standard deviation because z-scores are specifically about standard deviation. So now we're going to jump to median. We kind of left median on the table for a little bit there. So we're bringing it back, and the rest of this class is about median, except for the lab, but that's a different thing. All right. So we've already been calculating median, but now we're going to talk about quartiles. So what quartiles do is they split the data set into 4 equal pieces. So our first quartile is the bottom 25%. We use Q1 for quartile 1. The second quartile is the second 50 or second 25% of the data, and it separates the bottom half from the top half. So you can see this diagram is probably more useful than any words. So this diagram right here, if I was taking notes, this diagram is what I would put in my notes. So the second quartile is the second 25%, and it goes right up into the median. The third quartile is the third 25%. It goes from the median up to the last 25%. And then mhm. And then we don't have a fourth quartile, but this is, you know, that it just separates it like that. Okay. So I'm going to show you how to create quartiles. I'm going to show you how to find them. Super, super simple. If you can find median, you can find the quartiles. But this right here is the diagram that I would put in my notes if I were you. Unless you already printed the PowerPoint, then it's already there. All right. So the way that we find quartiles, once again, you take your data and you arrange it from smallest to largest, and then find your median. And we don't call the median Q2, but technically it's Q2. So find the median. Then what you do is you take the bottom half of the data set uh, below the median and you essentially find the median of the bottom half. That'll be Q1. Then you jump to the top half and you find the median of the top half. That's Q3. Don't worry, we're going to do an example and it's going to all make sense. Okay, here's my data set. I already arranged it from smallest to largest because I'm so bad at writing those. So, a group of Brigham Young University students collected data on the speed of vehicles traveling through a construction zone. So there are 14 vehicles traveling through a construction zone, and this is their speeds right here. So what we're going to do is we're going to find the quartiles, and the word interpret, it makes it seem like it's much more difficult than it is, but it is just not difficult. Okay, so there are 14 vehicles. So my median is going to be smack dab in the middle. It's going to be between 7 and 8. So my median, my median is going to be right here. So the median is smack dab in between. So my median is at 32.5. That one was real easy. I didn't have to add those together and divide by 2 because it was just easy. Smack dab between 32 and 33 is 32.5. Okay. So now that I've found the median, now I need to find Q1. So quartile 1 is going to be the median of the bottom half. So it's going to be the median of these 7 data values right there. So it'll be the fourth one. So this right here is Q1. That's Q1. And to find Q3, it is the median of the upper half. So it'll be right here. This is Q3.
So going off your last slide where it shows the so would 20, 24, and 27 be the 25%, or do you add that first quartile in with that 25%?
That's the weird thing is it's never super clear. It's never I hate this. I'm sorry. It's never super clear. I think that some books say yes, it's part of it, and some books say it's not part of it. Just like when I have an odd number, it's the middle term. So 50% is below the median and 50% is above the median. We kind of don't include the thing on the cusp. It's just very strange. I don't think anybody's going to be mad at you either way.
Okay,
I'm sorry.
you're fine.
We don't deal in absolutes. That's what I'm going to throw at you. So all the interpret is saying is this is 25% of my data. This is 25% of my data. This is 25%. And this is 25%. That is all the interpretation that we're doing. So I said the word interpret, I don't really like that there because that's all they're looking for interpreting is they just want to know where that 50% of your data is below the median, 50 is above, 25% is below Q1, 25% is between Q1 and median, 25% between median and Q3, and then 25% above Q3. And that's it. It doesn't get more complicated than that for finding your Q1 and Q3. Once again, though, if you have an odd or an even number, if you have an even number at the bottom, like let's say, no, don't draw this. I'm going to erase everything on this screen. So actually, I don't want all of it erased. I'm going to erase the Q1 and this stuff right here. Uh-oh. I didn't want the 3 to disappear. Okay. I'm just going to erase this stuff and we're going to pretend for a moment that I'm going to get rid of these. Let's pretend these aren't here. So if I had, so if I had this, so what we have now is we have an even number below the median. So just like with the median, you would my Q1 would be 28.5, and then my Q3 would be 37. So if you have an even number below the median, you still do the same thing where you average those two numbers to find that middle term. So we do the same thing. We treat it just like it's another median, but this would be the Q1 and this would be Q3. So I just wanted to point that out. So when you have those even numbers there, you're still finding that middle value. Right. Any more questions here? All right. This is the interpretation, as I just said, 25% of the speeds are less than or equal to the first quartile, 75 are greater than or equal to that, or greater than that. 50% of my speeds are less than or equal to the second quartile. This is just basically what I just said with those 25%. So I'm just going to move on. All right. So I arranged this in order. From smallest to largest. So what this is are 18 uh, collision coverage insurance payouts for different vehicles that had accidents. So it's a random sample of 18 claims, and we want to know where Q1, Q3, and the median are. So I'm going to give you a second. I would like you to try this. I will work quietly behind you. So there are 18. So that tells you how to count them, and go ahead and find Q1, Q3, and the median. Not in that order. I will work quietly behind you. How did we do? We are going to keep using this data for the next thing that we're doing. We're going to keep using the highway loss data. Any questions on Q1, Q3 median? Okay. Let's talk about interquartile range. So interquartile range is the median's answer to standard deviation. So it kind of shows us how spread out our data is. So instead of standard deviation with median, we use interquartile range. All interquartile range is Q3 minus Q1. It's the middle 50% of our data set. So it's from Q1 to Q3. That's interquartile range, or IQR. We almost never say the words interquartile range. It just kind of jumps to IQR, and because it's a mouthful to say. So we just call it IQR. So we're going to find the IQR of the speed data. So our Q3 was 38. My Q1 was 28. So 38 minus 28, my interquartile range is 10. So the middle 50%, the range of that middle 50% is just 10. That's my interquartile range. It's really just that simple. What we use the interquartile range for is to find outliers, and we're going to do that in a minute. Okay. So This is just kind of a, I want to show you how mean, median, and standard deviation and IQR and everything is affected by outliers. So this just kind of give you an idea of why we use median. So a 15th car traveled through the zone going 100 miles per hour. So let's take a look at how the mean and the median were impacted by that 15th car. So my mean of the construction data was 32.1. Once that 15th car came in, it jumped by 4.6 miles per hour. Take a look at the median. Without the 15th car, it's 32.5. Once that 100-mile-an-hour car came through, it only moved to 33 miles per hour. My standard deviation without the 15th car is 6.2 miles per hour. With the 15th car, my standard deviation jumped to 18.5. That's a huge difference. The IQR just went from 10 to 11, so it hardly moved at all. So if you have a nice symmetric bell-shaped distribution, you're going to use mean and standard deviation. If you are skewed left or skewed right, if your data has outliers, if it's skewed left or right, using the median and interquartile range is a good idea because it is not going to be skewed and pulled by the outliers so much. All right. Questions? Are we doing okay so far? All right. So the way that we check for outliers using quartiles is we find fences. So fences are the boundaries for our outliers. Any value higher than the upper fence and lower than the lower fence is going to be an outlier. The way we determine our fences is we take the IQR and you multiply it by 1.5. Then you take that number and you subtract it from the Q1, and that's going to give you your lower fence. You take that number and add it to Q3, and that's going to give you your upper fence. So any data value outside those fences is going to be an outlier.
Okay, Melissa, can you explain that one more time as far as the fences? You said that you divide it by 1.5?
Now you multiply by 1.5, so you take the IQR and you multiply it by 1.5.
Okay,
And you subtract that number from Q1, and that gives you your lower fence.
gotcha. All right, that makes sense. Thank you.
Add it to Q3, and that gives you your upper fence.
When I type it into the calculator, I do it like backwards. I still get the same answer. I do 1.5 times 4.2 plus the Q1, or I mean Q3. Does that
Yes.
make sense?
Yeah.
Okay, because the way it's row, I figured out a different way that made more sense to me because I felt like I was doing Q1 minus, I just goes back to PEMDAS to do the parentheses first, but I was
Yeah.
just throwing it out there.
No problem. All right. So let's do an example. So speed data. So once again, I have my Q1 is 28 and my Q3 is 38. So my interquartile range was 10. So I take 1.5 times 10, and you're going to subtract that from 28. It gives you 13 miles per hour. If any of the speeds were lower than 13 miles per hour, it would be considered an outlier. So once again, 1.5 times my IQR. IQR was 10. Add it to 38. So when I add that to 38, I get 53 miles per hour. If any of my cars went faster than 53 miles per hour, then there'd be an outlier. None of the cars were below 13 or above 53, so there are no outliers here. The collision data is going to be a whole different story. We're going to do that in a minute. Okay. So let's do it with the collision data. So my median, we don't even care about the median. Q1 is 735. Q3 is 4668. So my IQR is going to be 4668 minus 735, which I think I have it written down, is 3933. This is IQR. All right. So to find my lower fence, I'm going to take my Q1 minus 1.5 times 3933. This number is going to be a negative, and obviously it's a weird number. Negative 5164.5. Clearly, we don't have any lower outliers and nothing's below the lower fence, because that would mean that I improved my car by $5,000 when I wrecked it, which doesn't make any sense, but that's what that would mean. So let's try the upper fence. I'm going to take my Q3 plus 1.5 times 3933. Put that in my calculator. And I have $10,567.50. I have one outlier here. I have a data value that is $21,147. That is an outlier. That number is higher than my upper fence. Therefore, it is an outlier. It's unusually big. Questions? All right. Move forward then. All right. 5-number summary. Now, for some reason, 5-number summary seems to get a lot of people every term. Every term it seems to mess people up. I think part of the reason is because it's just maybe people think it's too simple, too simplistic. 5-number summary is just a way to not have to look at the bulk of the data. It's especially useful when you have something like a super large data set. If I have like 80 or 90 numbers in my data set, I don't want to have to keep digging through them all the time. So the 5-number summary is a great way to break it down to the important numbers. So if I say I have a 5-number summary, I don't have to label each number and what it is. We organize it just as follows. We give you the minimum number, Q1, the median, Q3, and maximum. That's it. You just write those numbers down. If you know that's a 5-number summary, you write that that's what the numbers are. The first one is going to be the minimum, the second one's Q1, third one's median, fourth one is Q3, and the fifth one is the maximum every single time. So it just breaks it down to the most important numbers, and you can do a lot with just those 5 numbers. I believe there's a question in the homework that gives you the 5-number summary and it asks you some questions about it. Do not be tempted to try to find a new Q1 or a new median or anything. It gives you all of those. It is not a data set. It is a summary of the data set. So let's get the 5-number summary of the speed data and the collision data. So I'm going to have to go back to my speed data because I don't remember all the numbers. So my speed data, I wish I would have had it. Oh, I do it. Hold on. I have I have the PowerPoint on my computer. Okay. So go back where we are. Okay. So the speed data, my lowest value is 20. My highest value is 40. This is usually how I build a 5-number summary. My 1, 2, 3, 4, 5, 6, 7. My median was 32.5. My Q1 was 28 and my Q3 was 38. That's it. Just write the numbers down. Let's do the 5-number summary of the collision data. The lowest number of the collision data. Once again, I need to pull up my This isn't when it's nice to have 2 computers. My lowest number for the collision data is 180. My highest number for the collision data, 21,147. The median, 1805. Q1, 735. And Q3 is 4668. Not bad. I'm having issues here. I don't know where by. All right, there we go. So you don't have to label them. If you know it's a 5-number summary, you don't have to label them. It is just what it is. So if I don't think I ask you for a 5-number summary on the test, but if I do, just list 5 numbers. You don't have to label them. Questions about a 5-number summary? Okay, moving on. Okay, box plot. I'm telling you right now, on the test, you are going to be asked to draw a box plot. So make sure to take any notes, any good notes for this. You will be asked to draw a box plot. And we are gonna draw one together. I'm gonna tell you what they look like and all of that. And then we're gonna draw one together. So the first thing we're gonna do with the box plot is you're going to draw a number line. The number line needs to be big enough to include all of your values. The number line is just a standard number line. You are not listing the values on the number line. You're not just listing your data values. You're just drawing a standard number line. Then you're going to draw a vertical line where I'm going to just go to a box plot to show you. Because I mean, there's all this here, but I feel like showing you is better. Okay, hold on. Okay, so this line right here, do not label these things. Your box plot should look just like this. You don't need to label what things are. I'm going to label what they are for you here just so you can see it, so you can write it in your notes. This right here is the median. So the first thing you do after you have, notice my number line is standard. All of these values here are what my box plot is. None of these are listed on my number line. Your data value should not be listed on your number line. So the first thing you do is you draw a vertical line where the median is. So I just drew that vertical line where the median is. Then I'm going to draw 2 more vertical lines where my Q1 and Q3 are. That's Q1 and that's Q3. Q1, and this right here is Q3. And then enclose them in a box. Then you just enclose them in a box. This is the box part of your box plot. Do not draw the whiskers yet, because the next thing you want to do is you want to find your fences. So remember, the fences are the boundaries that enclose all the usual values, everything that's not an outlier. So fences look like this. It's like a little bracket. So here's my lower fence. It's at 8.4. Here's my upper fence. It's at 18. The whiskers on your box plot, the whiskers go to the last data value inside the fence. So I'm going to draw down to here, draw to here. I'm going to label what these are. Whoa. I'm going to put this right here. I'm going to say what I just said, last data value inside the fence. Hold on, that was ugly. Your whiskers will not go all the way to the fence unless your last data value is at the fence. But your whiskers don't go to the fence. They go to the last data value that's inside the fence. Finally, you're going to indicate the outlier with an asterisk. There's my outlier. Your outlier lives outside the fence, and it is an asterisk. That's it. There's your box and whisker plot. I'm going to give you a moment to label your own notes.
So when you say that we have to draw our own box and whisker plot, which it doesn't matter either way, but are all the numbers already going to be there and we just have to draw it how the values are?
Yeah, I'm going to give you a data set. And
Okay.
so you will be you'll have scratch paper where you're doing all your work, showing your work. And you're going to have to, in your scratch paper, draw a number line and draw the box and whisker plot with the data set that I give you, which includes finding the outlier and all of that.
Is the bottom line with all the numbers, are those always, oh no, okay. So is there always the little dash for like the 6.5? So you go 6, 6.5, 7, 7.5?
Whatever scale works for you. So you'll see when I do the collision value, I'm gonna count by thousands
Oh,
because
okay.
yeah, so just whatever scale is gonna fit all your data.
Okay.
Yeah. These are great questions. You're really good at those good questions. Okay. Let's do the collision data. We're going to do this together. Now, I've been teaching this class for a little while, so I have drawn this number line quite a bit. I did it wrong a bunch of times before I did it right. So I've learned counting by 1,000 with just little tick marks for 500s in between works really well for me. So I'm gonna come down here and I'm gonna draw, well, that's really ugly. Okay. I'm gonna draw a nice long number line. Woo. And I'm going to go all the way there. Okay. There we go. And I know in my knower that counting by 1,000s is good for me. 0. And I usually put another tick mark for for 500. Because if I was writing all those numbers, it'd be tough. I'm going to show you something here. Oh, that's weird. Yeah, don't do that. Okay. All right. So we have a big break. So we have a data value that is 10,036, and then it jumps all the way to 21,147. I don't want to have to write all those numbers. I'm going to go to 11,000 here. And then I'm going to do something called put a break in my graph. So if you ever skip a large number of numbers in a graph, you can do something called put a break in your graph that like basically indicates that a big chunk was cut out. So I'm going to do that right here. That right there is indicating that I cut out a huge portion of my graph because I didn't want this big blank space between 11,000 and 21,000. So now what I'm going to do is this will be 21,000 right there. So I have a big chunk. I have a 10,000 chunk cut out of the middle of my graph. It's absolutely okay as long as you put the break in your graph. Put that little squiggle right there. It shows that I cut a big portion out of my graph. It's absolutely allowed. Every single math class that I've taught or been in has allowed that, but you just need to show that you have that break in the graph. All right. So here's my data set, or this is my number line. Notice it is just a standard number line with regular increments. All right. First thing I need to do is I need to indicate my median. Median is 1805. So my median is right about here. These are not going to be exact. You're just going to have to kind of guess where they go. Q1 is 735. So Q1 lives right about here. That's ugly. That's okay. Q3 is at 4668. So it's right about here. Okay. This is my box. There we go. That's the box. Okay, let's put our fences here. Notice I have a fence that is negative 5,164.5. It is kind of a meaningless fence. So usually what I will do if I have a meaningless fence like that is I just kind of put it over here. I don't even need to put a number on it, but if you wanted to label that that's negative 5,165.5, you can. You don't have to. Just kind of put it off the end of the graph and just kind of leave it there. Now, the meaningful fence is at 10,567.5. So right about here is my meaningful fence. That one's important because that one, I'm going to move it a little bit because I don't like how it's, I don't like how it's lower. Okay. Anyway, that's the meaningful fence because I do have an outlier, so that one is meaningful. Now, my whiskers are going to the last data value inside the fence. So the last data value inside the fence. So my lowest value is 180 inside the lower fence. So this is going to go right about, that's about 180. My last data value inside the upper fence is at 10,036. So I'm going to draw this whisker all the way up to right there. So my last data value inside the upper fence is 10,036. Notice the whiskers do not go to the fences. Finally, I need to indicate my outlier with an asterisk. My outlier is at 21,147. So I'm going to put my asterisk right there. And that's it. That's our box and whisker plot. Woo! That's it.
Can I just re-ask? So the whisker goes to the last data value that's not outside of the fence, and the
Yes.
same for the, okay.
Yes. So the last data value that's usual, that's not unusual, that's not an outlier. So most common errors on the test, the most common errors, people forget the outlier and they make their whiskers go all the way to the fence. Or they forget the fences altogether. Those are the three things that happen most. So take good notes on the box plot. I believe the whole box plot problem is worth 10 points, and 6 of them are the box plot itself, and 4 of them are the questions that are asked there. So make sure that you're paying close attention to the box plot. Other questions?
Will we be able to use the test review on the test?
Oh, yeah. Any notes you have generated, you may use. So if you print off the test review, absolutely. If you printed off these slides right here, absolutely. Any that you generated. If you take notes directly on the slide, those are now your notes. If you take notes directly on the test review, those are now your notes. You just can't use the book and you can't use a friend
Okay, thank you.
and you can't use the internet, but all right. So notice when you look at this, you can kind of see, this is one of the things I do like about box plots. I can see that I have a super long whisker on the right and not a very long whisker on the left. This is clearly skewed right. I love that you can see that from the shape of the box plot. One thing I don't like about box plots is the way Excel does box plots. When you do your final project, which I believe end of week 4, beginning of week 5, something like that is when I tell you about it. You can use a box plot in Excel, but Excel turns box plots up and down. It's really kind of ugly. It's a vertical box plot. You won't like it. I encourage you to check it out and see what it looks like, but it's ugly. I don't like Excel's box plots. All right, I have one more slide before we do the lab. So I'm going to pop over to this. This just kind of shows you that you can see how things are skewed. So back to the interest rates over here. I'm going to get rid of all the stuff that's on this one. So you can see that this one is skewed left. And you can see that this one is skewed right. If the whiskers are basically the same length on both sides of the box and your median is basically in the center of your box, then that would be a symmetric box plot. You can see how when we graph the data in a histogram and graph it on the box plot, you can see the skew there. And I find it kind of interesting. That's why I threw this on here because I found it kind of interesting. All right. So that is the end of the lesson portion. That's not the lab. That is the end of that. So questions on 3.4 and 3.5 before we move on to the lab. Okay. So I'm going to move to the lab, and the lab is kind of weird because I need to be able to, hold on, I need my controls, I think. We need to be, I hope I allowed other people to share. We will see. Okay, so when we're doing the lab, so lab 2, we have to enable some things before we can do lab 2. We need to enable the controls. I don't think I turned the controls off of this. Let me see here. I didn't. I'm going to turn it off so that I could turn it back on again. Okay. I'm going to turn it off on my other computer so I can turn it back on again. Just a second here. So I'm going to show you 2 different ways that, just a second. I'm going to show you 2 different ways to install the data analysis tool. I'm going to show you 2 different ways to do that because some computers do it, some computers do it one way and some do it another, depending on which version of Excel you have. My main computer, the one that you're seeing right now, this is on my MacBook. So this is the Excel that I downloaded on my MacBook. And I don't know if all MacBooks have it the same way mine does, but I know that I have a Mac Mini at work and it has the same version as this one. So I don't know if this is specific to Three Rivers School District or if this is just a MacBook thing. Anyway. So we need something called a data analysis tool in order to do today's lab. So when I click on data up here at the top, this says analysis tools, but I don't see anything that has descriptive statistics or a data analysis tool here. So I need to turn it on. So I'm going to click on analysis tools. Then I want to turn on the analysis tool pack. That's what we're looking at here. When I turn on the analysis tool pack, it shows the data analysis tool right here. And now I can use it. Once again, click on analysis tool. Wait. Click on data at the top, then click on analysis tools and check the analysis tool pack. This gives you an add-on that you need for this lab. I'm going to stop sharing on this computer so I can share on my other computer. Stop sharing. Okay, I'm going to share on my other computer now. Uh-oh. Need to send myself a request. Let's allow. Okay. Okay, so I'm going to share over here now. Share. Okay, so this is a different version. Okay, just a second here. There we go. This is a different version of Excel. This is the one that seems most common. I'm going to, once again, when I click on data, this right over here on the right is blank. There's nothing there. That's where the tool is. That's where the tool is going to be. So I'm going to click on File, go down to Options, and I want to go to Add-ins. So File, Options, go to Add-ins. Down here at the bottom is Manage Excel Add-ins, and I'm going to click on Go. I'm going to click on checkbox Analysis Toolpack and Analysis Toolpack VBA. Those are the two things that I'm turning on. So Analysis Toolpack and Analysis Toolpack VBA, and click OK. Notice now it says Data Analysis. I'm going to walk you through it one more time. Click on File and Options down here at the bottom left. Go to Add-ins. And then down here, Manage Excel Add-ins, click Go. And you want Analysis Toolpack and Analysis Toolpack VBA. And then click OK, and it'll have the data analysis tool here. Now this is where all computers are the same now. I need to move stuff so I can stop sharing. Go back to my regular computer. Okay. Now we're back in Excel. Okay. So now that we have the tool pack added on, everything you do in today's lab needs to be done with Excel tools. You're going to be graded on whether or not you're using Excel tools. So the first thing I'm going to do is I need to get my data analysis tool. So I'm going to click on data analysis and scroll down or scroll up. What I want is descriptive statistics. So click on data analysis and go to descriptive statistics and click OK. My input range, this is going to be my data. Input range is my data. I'm going to highlight all of my data here. I have so much. Okay. Once I highlight the data, it's going to show that right there. I want summary statistics. So check the box for summary statistics. It's going to give you all the stuff that you want. My output range. So for the output range, I want it to land in this box. So I'm just going to highlight this box right here because that's where I want it to land. That's the output range. So once again, check the box for summary statistics. Highlight the entire box here for output range, and the input range is your data. And when I click OK, this is lovely. Okay. What this gives me, a whole bunch of stuff. You'll learn about standard error later on. Here's my mean, here's the median, there's the mode, my standard deviation, variance. We don't even care about variance. It's the minimum and the maximum. It gives you the range. It adds them all up. It tells you how many you have. It does all sorts of cool stuff. So what I would like you to do is I want you to use the actual Excel tools to populate your fields. So every time you do any math, you're trying to populate anything, you want Excel to do stuff, you need to put an equal sign. Equal sign is telling it that some sort of an operation or something is coming up. So in order to input the mean, I'm going to click on the box for mean. Then I'm going to click equals. And then click on this number here, what the mean is, and then hit enter. It just populated it. Standard deviation, I'm going to click equals. Then click on the number for the standard deviation right there, and then click enter, and it populates it. I'm going to come back to number 2. We're going to leave number 2 alone for a minute. Median, once again, click equals, go up here to median, click on that button, and hit enter. Mode, equals, click on that, hit enter. For number 4, I don't want you to use this skewness number here or kurtosis number. I don't want you to use those. What I want to know is based on your mean and your median, how is your data skewed? So I want you to go back to when it said if the median is greater than the mean, this is your skew. If the mean is greater than the median, here's your skew. So my numbers are really close to the same. They're almost the same number. Therefore, my data is symmetric. So I would type something in here and say my mean and median are almost exactly the same. Therefore, my data is symmetric. That's what I would put there. So I want you to talk about the relationship between your mean and your median and what that says about the skew of your data. Okay. 5-number summary. The lower value equals the minimum. Enter. Q1. So take a look here. I'm going to start typing the word quartile. So right here, I started typing the word quartile. I want quartile INC. And then I will highlight my data because it says array, quartile INC, highlight the data, and then comma, I want the first quartile. So hit 1, close your parentheses and hit enter. So once again, take a look up here. I can't, up here on my bar here, quartile.inc, highlight all your data, then comma, the quartile you're looking for. Quartile 2 is just the median. So once again, enter that in. Quartile 3, I hit equals, type in quartile, INC, highlight all of the data. Once again, okay, comma, quartile 3, enter. High value is just my maximum, so equals my maximum, enter. So for IQR, we're going to be doing math. Take a look here, hit equals. I want to take Q3, so hit check on that, minus, put in the minus, Q1, and then hit enter and it'll do the math for you. All right, finally, what I want you to do in number 2, there's 2 different ways to do this. So we're using z-scores. So for looking for your unusual data, you are going to use the two standard deviation rule. So the different ways that you could do this is you could calculate using your standard deviation. I could take my mean, I can take my mean, equals my mean plus 2 times standard deviation. And that would give me my, what did I do? Okay. That would give me okay. No, what this gave me is the number that if any of my data values are above that number, it's an outlier. Then I would do the mean, equals mean minus 2 times standard deviation, enter. That gives me the lower value. Any value below that would be an outlier. That is one way to do it. The other way you can do it is you can calculate the standard deviation or the z-score of your lowest and highest values. If you calculate the standard deviation of your lowest and highest, or the z-score, sorry, of your lowest and highest values, then you can refer to those and say, oh, this one has a z-score of 2.08, therefore it is an outlier. You can do it either way. Now on number 2, I am not requiring you to use Excel tools to do your math. I did here because it's fun. You don't have to use the Excel tools, but you do have to reference z-scores. You do have to be specific referencing z-scores to tell me if you have outliers. Remember, any z-score above 2 or below -2 is an outlier. All right, that's it. Now I would like you to ask me any questions you have about the lab. I know it was a
If you
lot.
if you had multiple outliers, would you need to figure out, like if you suspected you have a few upper values, you need to figure out the z-score of multiple?
Or I mean, if, for example, like my lower bound is 4.84. I have three, 1, 2, 3 outliers, lower outliers. If I figured out that 4.7 is an outlier, I know 4.4 is an outlier. So if you find out that one is, you know that any beyond that are also going to be an outlier. So you can just show me the one, show me, hey, 4.7 is an outlier. And then obviously 4.4 is also an outlier. You can just mention it.
And on your question one part of this, you highlighted S equals, but you did the standard deviation, but does that S really reference the sample? Or
Yes, but it doesn't matter, right? It just calculates standard deviation. I don't care that it is I don't care that it's the population standard deviation. It doesn't matter to me. It's not that big of a deal. Just use the standard deviation in your descriptive statistics. Because
Can you show how to do Q1 and Q2 and Q3 again?
yep, so the Q2 is just the median, so just put the median value in there. I'm going to erase this and I'll do it again. So equals, just start typing the word quartile and you'll see it come up. And just choose quartile.inc. And I don't care if you use INC or what is it, EC? All it's saying is quartile including, so it would include that endpoint. So remember what we were talking about if Q1 and Q3 were part of the 25%? Excel makes that distinction. So let's see here. So EXC means excluding the Q1 endpoint, and INC means including it. It doesn't matter. You're actually going to get the same number either way. So once you put quartile INC, then you just highlight this array means to highlight your data. Whenever it says array, it wants you to highlight your data. So I'm just going to highlight all of my data. And then once I come back up, it's just going to show up and then hit comma. And I want the first quartile. So I put 1 and then close the parentheses and then hit enter. Once you do it, it's pretty user friendly.
Okay, thank you. That worked.
Yeah, it looks a lot harder than it is.
I do have a question about the descriptive statistics.
Yes.
You didn't say to put anything in the input range, just the output range, correct?
No, the input is your data.
Oh,
So
okay.
when I click on it, click on it, this input, this is the data. So my raw data, I just highlighted all of the raw data on input.
Okay.
The output range is where you're putting it,
Where you're putting it. Okay.
Yeah.
Thank you.
These are great questions. Right. Anything else? So for lab 3, we'll be doing lab 3 on Thursday. On lab 3, you're going to need two variables that are like on the same thing. So for example, you could use like somebody's shoe size and their height. You could use this is really great, like somebody's height and I don't know why basketball is in my head. So you could put like somebody's height in inches and how many points they scored that year or that season for basketball. So you're going to need two variables that you think are probably correlated. So you could do pick 20 cities and put their high temperature and precipitation for the last 20 years, or try not to put too much effort into it. Find some site that has some good data that you can get both of them on. You know, that's why I like things like sports because there's a lot of data there. You could just look at players and look at like, you know, the like weight and rushing yards of football players, things like that. And I don't care if it's discrete or continuous, it doesn't matter. It does need to be quantitative, but it can be discrete or continuous. So you'll need 20 data values that are with two variables, 20 data values each that you think are correlated. That's what for lab 3 on Thursday.
But the units can be different, like years and money.
Oh yeah, absolutely. Yes. It could be, you could even do like age and education level, things like that. But they need to be numerical. So you could do education level. You could always count up from 12. That's usually when I do education level, I'll do that if I want it to be quantitative. So like a bachelor's degree would be 16 because it's 4 years of college. And then a master's degree, depending on if it's 2 years or 1 year, could be 18. So, however you want to do it. But um, it doesn't have to be something perfect and super meaningful because it's really about learning to use the tools. Meaningful will be your final project. So just find something easy. Sports are always super easy. Right.
Could another, oh, sorry.
No, go right ahead.
I'm just curious, could another one be like birth weight and current weight?
Oh, yeah. Absolutely.
Okay,
Go for it.
thank you.
Just make sure that you don't do pounds and ounces that
Right,
yeah,
convert all to ounces.
yes, or all the pounds,
Okay.
or whatever, because otherwise you're going to be really messed up and you're not going to like it. But you could do birth weight as ounces and then current weight as pounds. That doesn't matter.
Okay, thank you.
Uh-huh. Anyone else?
For the IQR on the current lab, can you show how to get that again? Because I keep getting a negative number, and
Okay.
that's just like with me calculating it, not using the Excel.
Okay, so click equals, and this equals is saying I'm going to tell you to do something. So it's Q3 minus Q1. So after I hit equals, I click on the Q3 number, then minus, and then click on the Q1 number, and it will do the subtraction for you. And I know it's super easy to do it on your own, but the idea is to learn how to use the Excel tools. That's like the whole point.
Okay, thank you. My number's still negative. Is that okay, or did I do something wrong, like up in the
Something
calculation?
went wrong. Is your are you sure that your Q3 is a 3 here? So click on
I
your,
can double check.
yeah, make sure that you didn't swap your Q3 and your Q1 because your Q3 should be a higher number than your Q1. So yeah, pay attention to that.
And I can just write NA if there's no mode.
If there's no mode, yeah, just write NA in there. Or it'll say NA right there. And I don't care if you populate that or not. You don't have, if it's NA, you don't have to populate it. Unless you want to. Sometimes I get on a roll. I love Excel. Excel is like my guilty pleasure. I can play with it all day. I'm a spreadsheet girl. All right, anybody else? For while we're being recorded.
For the discussions, do responding to other people's discussions count as participation, or do you need to create your own?
No, you do not have to create your own. Any participation, I just need you to participate one time a week. That's it. However that is, helping somebody else. I almost feel like helping somebody else is more valuable than posting your own sometimes. So yeah, just one participation in the discussion per week.
Okay, thank you.
You're welcome. All right, anything else on recording? Okay, I'm gonna stop the recording.